All right, let's talk about your code. Is it in good shape? Or is it, one bad day away from a total meltdown? Today, we are giving your software a full physical. We're going to use something called object-oriented metrics. These are basically powerful diagnostic tools that let us measure the health, the complexity, and the maintainability of your design. Let's dive in. You know the feeling, right? We have all been there. You go to change one tiny little thing in the code, and boom, something totally unrelated just breaks. Or maybe you're just staring at this one massive class that seems to do 20 different things, and you are absolutely terrified to even touch it. That, my friends, is the pain of unhealthy code. But what if you could actually measure that health before it becomes a full-blown crisis? Well, that is exactly where OO metrics come into play. Seriously, think of them like a doctor's toolkit for your codebase. They give us real, concrete numbers to help us evaluate quality, to spot those potential code smells, those little hints that something much bigger might be wrong under the surface. It's all about checking the overall health of our design before a small problem spirals into a system-wide disaster. Okay, so to start our checkup, we're going to look at one of the most famous toolkits out there, the CK metrics. These were proposed by Chidambar and Kamer, and this suite gives us a fantastic starting point for assessing the quality of pretty much any object-oriented system. First up is WMC, which stands for Weighted Methods Per Class. Now, while you can get fancy and assign different complexity weights to each method, it's most often used in its simplest form. You literally just count the number of methods in a class. That's it. It's a super direct measure of how much a single class is trying to do. So take this customer class, for example. It's got 4 methods, right? So its WMC is 4. That feels pretty healthy, pretty reasonable. But what if it had, say, 20 methods? Well, a high WMC is a huge red flag. It's a really strong sign that your class is probably violating the single responsibility principle, making it this bottleneck where any tiny change carries a high risk of causing all sorts of side effects. Next up, let's look at inheritance with DIT, or depth of inheritance tree. This metric is also pretty simple. It just measures how many levels deep a class is in its family tree. How many generations does it go back to the very first ancestor class? So in this classic example, the animal class is the root, so its DIT is 0. Mammal is 1 level down, so it's at 1. Dog is at 2. And finally, bulldog has a DIT of 3. Now, here's the critical trade-off. A deeper tree means the bulldog class gets to reuse a ton of code from its ancestors, which is great, very efficient. But it also means it inherits all the complexity from 3 other classes, which can make it way harder to understand and to test. Our third metric is CBO, coupling between object classes. Coupling is all about dependency. It asks a really simple question. How many other classes does this class rely on to get its job done? And trust me, you want this number to be as low as possible. Let's look at this car class. To be a car, well, it needs an engine and it needs wheels. Since it depends on those 2 other classes, its CBO is 2. So why does this even matter? Well, think about it. If the engine class changes, our car class is probably going to break. High coupling creates this really fragile domino effect all across your code base. The goal is always low coupling. That leads to modular, independent classes that are just so much easier and safer to maintain. Okay, now for one of my personal favorites, LCOM, or lack of cohesion in methods. This metric tells you if your class is a focused, single-purpose tool, or if it's basically just a junk drawer full of totally unrelated functions. A really cohesive class has methods that all work together on the same set of data. A class that lacks cohesion, well, it doesn't. So how in the world do we measure this? Well, the whole idea is to see if the methods are actually working together or if they're just operating in their own little worlds. We do this by looking at every possible pair of methods. If 2 methods use the same piece of data, the same attribute, we say they're connected. If they don't share anything, they're disconnected. The final LCM score just comes from comparing those 2 counts. Let's make this real with a book class. Okay, so the methods printTitle and printSummary, they're connected because they both use the title attribute. We'll count that as a connected Q pair. But printTitle and printAuthor, they don't share any data, so they're a disconnected P pair. So we go through all the methods, and we find this class has 3 connected pairs and 7 disconnected pairs. And that brings us to the final calculation. We had 7 disconnected pairs, that was P, and 3 connected pairs, Q. So P minus Q gives us an LCOM of 4. Now, the rule of thumb is pretty simple. If LCOM is a positive number, it's a sign of a lack of cohesion. This number, 4, is telling us that our book class might be a good candidate for some refactoring. Maybe we could split it into smaller, more focused classes. So the CK metrics are a fantastic starting point, but they are not the only toolkit out there. Let's just briefly touch on another perspective, the LK metrics from Lorenz and Kidd. These tend to focus a bit more on the nitty-gritty details of the class structure itself. Let's just look at 2 key LK metrics to get a feel for their approach. First is class size, or CS. This one's a simple but really powerful count of all the methods and all the attributes. Just like a high WMC, a high CS suggests that a class is just bloated and trying to do way too much. The second one is number of operations added, or NOA. This one is all about inheritance. It counts how many new methods a subclass adds that weren't in its parent. A high NOA is a warning sign that your subclass might be turning into something that doesn't really fit the abstraction it inherited. So, we've gone through all these numbers, all these calculations. What's the prescription? I mean, how do we actually use this information to write better code? The absolute key is to think of them not as strict rules, but as helpful guides. So, what's the bottom line here? The most important thing to remember is that these metrics are not absolute laws. A high number isn't automatically bad. Their real power is as a diagnostic tool that helps you spot those code smells, those warning signs of deeper design flaws. You should use them to guide your design toward that sweet spot, highly cohesive classes with low coupling between them. Ultimately, they just empower you to ask the right questions about the health of your code. So, as we wrap up, I'm going to leave you with a question to think about. Go pick a class you wrote recently, something you're working on right now. What would its health check look like? What is its WMC, its CBO? What story are those numbers telling you? Thanks for joining me.